For these cars to run, they need fuel, and that fuel is made up of octane. Octane is a hydrocarbon and an alkane with a chemical formula C8H18. The main use for octane is as an ingredient in car fuel known as gasoline. Octanes are considered a family of 18 isomers that make up most of the composition of gasoline, which is an engine fuel refined through the fractional distillation of petroleum. Petroleum, obtained by drilling, is produced through the decomposition over time of organic matter that has been compressed into layers in the Earth's crust. Petroleum is refined into four main fractions or levels of fuel, which are diesel, kerosene, gasoline, and refinery gas. Most of the product that results from petroleum is gasoline. Octane in gasoline is used in gasoline engines, which are also known as petrol engines. A petrol engine is an internal combustion engine with spark ignition. It was first invented in 1876 in Germany by German inventor Nicholas August Otto. In most petrol engines, the fuel and air are usually pre-mixed before compression. A petrol engine works in 4 steps: intake, compression, power, and exhaust. During the intake stroke, the piston moves down in the cylinder, creating a low pressure area, which forces a mixture of fuel and air into the cylinder. When the cylinder is filled with the mixture of fuel and air, the piston then forces the air up and compresses it into the cylinder. When the mixture is fully compressed, the power stroke causes the spark plug to ignite the compressed fuel, and the explosion forces the piston back down the cylinder. This is ultimately what powers our cars to move. The product left over is forced out the exhaust when the piston comes back up. This process repeats itself over and over again, which is how we drive from one place to another. The term octane becomes very important during the compression stroke. When you go to a gas station and you pull up your car in front of one of these pumps to fill up your tank with gas, you will notice some of these labels: regular unleaded, premium, or maybe even super premium. You also see different numbers labeling these choices for your gas. These numbers can range anywhere from 87 to 93 usually. What these numbers are they are the octane ratings for the different gas mixtures. Octane rating is a performance rating of petrol in internal combustion engines. An octane rating defines the level of petrol's capability of limiting knocking in engines. The higher a gas's octane rating is, the slower it will burn. This means when it's compressed inside the cylinder, it resists self-igniting more than an octane rating of lesser value. Knocking occurs because when the fuel is compressed inside the cylinder, it heats up, And if it's compressed too much, then it can actually self-ignite, causing the piston to move back down before it's supposed to. Knocking can actually cause damage within the engine of your car. Because of knocking, this is why when you're at a fuel pump, you should always buy the gas with the octane rating designed for your car. The higher this octane number, the more knock resistant the fuel is, and the more compression the fuel can withstand, which results in a more powerful explosion after ignition. A fuel's ability to prevent knocking is based on its ratio of branched chains to straight chain hydrocarbons. Higher levels of branched chains in a fuel are more efficient for high-performance engines, such as sports cars or race cars. To determine the ratings of octane mixtures used as gas stations, the MON and RON are used. The most common type of octane rating worldwide is the research octane number, which is RON. Research octane number is determined by running the fuel in a test engine with a variable compression ratio under controlled conditions, comparing the results with those for mixtures of isooctane and N-heptane. Isooctane, which is also called trimethylpentane, is especially knock-resistant isomer of octane rating of 100. At the other extreme, N-heptane is 0. The other type of octane rating, called motor octane number, which is MON, is a better measure of how the fuel behaves when under a realistic load. It is determined at 900 rpm engine speed instead of the 600 rpm for RON. Motor octane number testing uses a similar test engine to that used in RON testing, but with a preheated fuel mixture, a higher engine speed, and a variable ignition timing to further stress the fuel's knock resistance. Because of the composition of the fuel differs, the MON of a modern gasoline will be about 8 to 10 points lower than the RON, but there is no direct link between RON and MON testing. Normally, fuel specifications require both a minimum RON and a minimum MON. These methods have been used for over 80 years. The number you see on our pump measures the average of the RON and MON that were tested. Octane used as fuel is cheaper and is more commonly used than one of its competitors, diesel. Even the supreme grade octane gasoline isn't as expensive as diesel fuel is.